Blast off to the outer reaches of our solar system and journey to Saturn, the second largest planet in our solar system, and its mysterious moons with the Cassini mission. Prepare to be amazed by the breathtaking visuals and groundbreaking research from the Cassini spacecraft as it captured the stunning beauty and secrets of this distant planet and its moons. This is a once-in-a-lifetime opportunity to witness the incredible discoveries made by the Cassini mission and explore the mysteries of the outer solar system. Don't miss out on this incredible journey. What is Cassini's mission? The Cassini spacecraft orbited Saturn for more than a decade, giving us unprecedented insights into the planet's inner and outer workings. It was primarily a NASA mission, although it also included a craft called Huygens, built by the European Space Agency and the Italian Space Agency, that landed on the surface of Saturn's largest moon, Titan. The mission launched in 1997, flying past Venus and Jupiter on its way to Saturn. It arrived in orbit in 2004, and thanks to 3 mission extensions, it spent 13 years revolutionizing our understanding of the system. It took more than 450,000 images, discovered 6 named moons, and taught us about not only the Saturn system, but the possibilities for planets and moons everywhere. At the end of its mission, Cassini executed a maneuver called the Grand Final. It circled closer and closer to Saturn's cloud tops, between the planet and the rings. Then, on September 15, 2017, it plunged into the planet's atmosphere. This was the only way to ensure that it would never smash into any of Saturn's moons and contaminate them with any Earth microbes that managed to cling onto it. It continued transmitting data for 30 seconds longer than expected, but eventually, it burned up. Major discoveries at Saturn. Cassini provided a wealth of data on Saturn, enough for researchers to analyze for decades to come. It measured the rotation rate of the planet, which proved to be more complicated than anyone had suspected, using several different mechanisms, as well as the difference between the overall rotation and atmospheric motion. That atmospheric motion included enormous storms and jet streams that we'd never seen up close before, in addition to colossal hurricanes at the planet's poles. The craft also found lightning, taking the first videos of lightning on any planet beyond Earth. It also greatly deepened our understanding of the atmospheric makeup of the planet. Top 10 discoveries that Cassini did on Saturn. 1. The Huygens probe makes its first landing on a moon in the outer solar system, Titan. Huygens' historic 2005 landing on Titan was the most distant in our solar system to date. The probe's 2-hour and 27-minute descent revealed Titan to be remarkably like Earth before life evolved, with methane rain, erosion and drainage channels, and dry lake beds. A soup of complex hydrocarbons, including benzene, was found in Titan's atmosphere. Huygens also provided the first on-site measurements of the atmospheric temperature. 2. Discovery of active icy plumes on the Saturnian moon, Enceladus. The discovery of Enceladus's massive plume was such a surprise that mission designers completely reshaped the mission to get a better look. The discovery became even more important when Cassini found evidence of water-based ice in the plume. Life as we know it relies on water, so the search for life suddenly extended to this small bright moon. The recent discovery of signs of a subsurface ocean makes Enceladus one of the most exciting science destinations in our solar system. 3. Saturn's rings are revealed as active and dynamic, a laboratory for how planets form. Cassini's decade-long mission made it possible to watch changes in Saturn's dynamic ring system. The spacecraft discovered propeller-like formations, witnessed the possible birth of a new moon, and observed what may be one of the most active, chaotic rings in our solar system, Saturn's F-ring. 4. Titan was revealed as an Earth-like world with rain, rivers, and both visible and infrared wavelengths shows that Titan has many geologic processes similar to that of the Earth. These processes generate methane rains, which build river channels and form lakes and seas containing liquid methane and ethane that don't immediately evaporate. 5. Studies of the Great Northern Storm of 2010 to 2011. Late in 2010, Saturn's relatively tranquil atmosphere erupted with a storm of gigantic proportions. Typically a 30-year storm, this one arrived 10 years early, giving Cassini a front-row seat. Within months, this storm grew to encircle the planet with a swirling band. The largest temperature increases ever recorded for any planet were measured. Molecules never before seen in Saturn's upper atmosphere were detected. The storm diminished shortly after its head collided with its tail, a little less than a year after it began. 6. Radio wave patterns were shown not to be tied to Saturn's interior rotation, as previously thought. Saturn emits radio waves known as Saturn kilometric radiation. A similar radio wave pattern was measured at Jupiter to deduce the length of that planet's day, but Saturn's daily rotation rate turned out to be much more complicated. Recent data from the radio and plasma wave instruments show that the variation in radio waves controlled by the planet's rotation is different in the northern and southern hemispheres. The northern and southern rotational variations also appear to change with the Saturnian seasons, and the hemispheres have swapped rates. Saturn's length of the day is still not known. 7. Vertical structures in the ring's image for the first time. Once about every 15 years, the sun shines on the edge of the ring plane, and the northern and southern sides of the rings receive little sunlight. Cassini measured the thick, long shadows from this rare event to determine the heights of structures within the rings. 8. Study of prebiotic chemistry on Titan. Titan's atmosphere is a zoo teeming with a variety of molecules, the most chemically complex in the solar system, beginning with sunlight and methane. Ever more complex molecules form until they become large enough to form the smog that covers the giant moon. Nearer the surface, methane, ethane, and other organics condense and fall to the surface where likely other prebiotic chemistry can take place. 9. Mystery of the dual bright-dark surface of the moon Iapetus solved. The origin of Iapetus's two-faced surface has been a mystery for more than 300 years. The Cassini spacecraft solved the puzzle. Dark, reddish dust in Iapetus's orbital path is swept up and lands on the leading face of the moon. The dark areas absorb energy and become warmer, while uncontaminated areas remain cooler. The moon's long rotation period contributes to the yin-yang effect. 10. First complete view of the North Polar Hexagon and discovery of giant hurricanes at both of Saturn's poles. Saturn's polar regions have surprised scientists with the presence of a long-lived hexagonal-shaped jet stream in the north and two hurricane-like storms at both poles. The driving forces of each remain a mystery. In the remaining 3 years of Cassini's mission, scientists hope to learn more about the properties and conditions surrounding their existence. In conclusion, the Cassini mission has been one of the most extraordinary and groundbreaking missions in the history of space exploration. By studying Saturn and its moons, this mission has allowed us to gain valuable insights into the workings of our solar system and the potential for life beyond Earth. The latest advancements in space technology have allowed us to capture stunning imagery and groundbreaking data that have forever changed our understanding of Saturn and its moons. Don't forget to subscribe to our channel, or you will miss out on our videos.